Welcome students for the wireless sensor network class. Today actually we are going to see what is basically a wireless sensor network and how it is going to function, and what are the various factors that is going to influence the wireless sensor network design. Okay, let us start with the first thing is what are the components we are going to use in the sensor network. The vital components here is the sensor node, and second thing is the factors that is going to influence our network design, and what are the characteristics that is going to affect our design part and the implementation part. We are going to see that. Then finally the tiny operating system that has been included in our wireless sensor network, that what are the features of the tiny OS we are going to see. Then finally we will conclude with the wireless sensor network application. So first, if you see this diagram, you will come to know that this wireless sensor networks have been deployed for a particular application for sensing the information and transmitting the information to the user end via the sync node. Okay, so sync node is nothing but the base station, and the base station is there to send the information to the user end via internet. So when you see this sensor node, the sensor nodes are very vital, and they are going to integrate the physical world and the information world, you can say. And moreover, these sensor nodes, they have been deployed or self-organizing wireless network system. If you see, look at the feature of the sensor node, it is having the computing facility and communication facility, whereas the storage and power supplies are very limited. So what actually in the sensor node, if you see, the components include sensing unit, processing unit, and communication unit. All these three units have been connected to the energy storage device, that is nothing but a battery which is operated with 1.2 to 3.7 volts. So this is some of the specifications given for the sensor node components. What actually we use here, it is processor, memory, internal storage, vedio, the coverage range, and the operating system what we are going to use. So the design of network topology or the routing algorithms and protocols what we are going to develop are going to be challenging when we try to deploy more number of nodes for the wireless sensor network. So let us see the factors that is going to influence the network design. First, when we take the communication, the first thing is the transmission media, where you find the transmitter and the receiver side, which is responsible for the transmission. Then we have to go with the low power communication, because for the long range more power will be consumed. Next, we have to stick with multi-hop networking, and because single hop networking consumes more power. Then if you go for topology configuration, there is no fixed infrastructure for wireless sensor network. All these nodes are self-organizing, and moreover it is fault tolerance, and it is confined to the limited resource like our bandwidth and our channel bandwidth and our power supply. Then if the deployment features, if you see, it is deterministic or randomly deployed, and these sensor nodes are said to be distributed sensing in nature, and it is strict to the hardware constraint and the production cost. So this is some of the characteristics which is going to affect our application side and the architecture side. We will see. So first, the characteristics of the WSN can be listed like infrastructure less, that it is a data centric mode, and scalability, lifetime, resilience, programmability and maintainability, multi-hop communications, and application oriented with the limited resources. So when we go for application, we can see the two types of applications can be there. It is one is for monitoring the information and tracking the information, and second thing we have the architecture is for flat or hierarchical cluster based architecture, centralized, distributed, homogeneous or heterogeneous, static or dynamic. Second is the general work process of WSN. The figure clearly shows how the sensor nodes have been deployed, and second, the sensor nodes try to organize into a network for sensing the information and transmitting the information. So sensing and monitoring, the third figure is all this information sensed will be sent to the base station. And the data collection sometimes it's called as data aggregation, because all the sensor nodes try to aggregate the data and send to the base station. So they can think the goal of the sensor node, if you see the thing is actually it is to collect the data at the regular intervals, then transform the data into an electrical signal, and finally send the signal to the sync or base node. So if you see the operating system, what we are going to use in our sensor network is nothing but a tiny OS, where you can see it's a embedded operating system written in NetC programming language, and it is developed in 1999. So, and this operating system is a free open source operating system designed for particularly for wireless sensor network. So what are the problems we actually face when we stick with our wireless sensor network? It is existing OS is nothing but a multi-threaded architecture which is not useful, and moreover the large memory footprint and does not help to conserve. So these problems has to be solved, because we have to go with the tiny OS. So the recommend is like this: it is efficient utilization of energy and power, small footprint, should support diversity in designing and usage, more emphasis on concurrent execution. So if you go for the features of TinyOS, you can see that it is a component based architecture that allows frequent changes while still keeping the size of the code minimum. And second thing is, it's an event based execution model, means that there is no user kernel boundaries and hence it supports high concurrency. The power efficient as it makes the sensor sleep as so. So these are some of the applications we can list for the wireless sensor network, like water quality monitoring, air pollution monitoring, forest fire detection, automotive application, landslide detection, and military application. So first, when we go for a forest fire detection, there's a network of sensor nodes can be installed in a forest to detect when a fire has started. Second thing, how it is going to detect all the nodes having the sensing capacity. So try to detect the fire and it sends an alarm message to the base station, which is located at a far distance. So these nodes can be equipped with the sensors to measure the temperature, humidity and gases which are produced by the fire in the tree or vegetation. Second application, if you see, is air pollution monitoring. That is a traditional air quality monitoring method such as building air quality monitoring stations are typically expensive. So we have to stick to the alternative. We have to look for it. Whereas in the case of wireless sensor network, the solution to this is air quality monitoring system based on the technology of the wireless sensor network, and moreover these sensor nodes that has been deployed in several cities will try to monitor and monitor the information like the concentration of dangerous gas that has been in the citizen, for the citizen. Second, water quality monitoring involves analyzing water properties in dams, rivers, lakes and ocean as well as underground water reserves. So here what parameters actually the sensors will try to look for: temperature, turbidity and pH value. So landslide detection is also possible with our wireless sensor network to detect the slight movement of soil and changes in various parameters that may occur before or during the landslide. So already we can look for the previous data that has been collected, and so that we can estimate when it will be the occurrence of the landslide actually based on the data what we have collected, when it will occur. So this is general application like a military application using wireless sensor network, where it is possible for enemy tracking, battlefield surveillance. Second thing, target detection we can do, then monitoring and tracking the surveillance of borders, then the nuclear, biological and chemical attack detections. So this is direction nothing but the direction of earthquake. So node select detects the seismic event and each node sends event report to the base station. So future scope, what one point I can highlight is they receive the live information from the road authority about the state of the roads, including traffic jams, accidents and weather. And moreover, the car inbuilt to the cars transmit the information to the road authority regarding the speed, distance traveled, use of the windscreen or wipers through wipers. So I think you would have a clear idea about the applications of wireless sensor network. So the conclusion here it is the WSNs are widely applicable major emerging technology, and WSNs are getting smaller and faster, increasing their potential applications in commercial, industrial and residential environments. So however, the limit of application depends only upon the sensors used and the interpretation of the data obtained. Thank you. We'll see in the next class.